Hi and welcome back to the Naval Tech Tinkerer. Behind me, I think you can see it now, is a 4-axis foam cutting CNC. I was actually sick last night, so it's like 6 p.m. right now and I'm starting to feel better. So I questioned if I could make a quick video of how I built this. So this is for you. Hope you enjoy it. What you see in front of you is a 4-axis CNC that is cutting foam. You can see I've done plenty of test cuts with it and tried to get these different shapes out. Like, we can take a quick look at it. So here is one trial. They are super lightweight, and you can kind of see the airfoil that you would use to produce a drone or an RC plane. Of course, it wouldn't just be this. You would actually cover this with glass fiber, or you would add carbon fiber. I will add carbon fiber. You just wet lay and put some pressure so that you can sand it really smooth, or just use pressure to make it extremely smooth. But that's not what this video is about. It's about the 4-axis CNC. So this is kind of an overview picture of it. You have the foam hanging up a little bit in the air. You usually put some weight on it so it doesn't move around when that wire cuts it. So here's another view. As you can see, I have built it with steel and aluminium extrusion here, and it goes all the way through here. It's kind of hanging in the air to be hugging this from both sides, so that these V wheels, which turned out to be not that great of an idea, was gonna be solved. So let's look at how this carriage works. Well, first you have a frame, just the basic frame. I think there are better solutions to this, but we can get into that later, what I would have done. This is my own design. And of course it would have been so much better to pick somebody else's, but I had parts and I wanted to use them. Then I 3D printed in PLA this carriage, and the problem I had initially was that the forces here between, pulling inwards, were a bit too large. So I had to beefen these up and make sure that it's quite stable. As you can see here, it moves. It uses Omega drive, which means it has this GT2 belt, and it goes up to a pulley here and down again. So you can kind of see the wheels pull it down. And that's kind of a design feature I wanted, because I don't like these things flying everywhere. I wanted as little things possible flying around in the air, and now it looks solid. So then you can see I have aluminum extrusion. In the beginning, there was just too much flex in this direction, or in the torsional axis, and I needed to beefen that up. So me and my friend that you saw in the previous video, we just made holes, like 2 holes here, and then we just bolted it in there. You can kind of see I've cut those bolts off and repainted here, which I of course forgot there. But anyways, I don't care, it works. So that's the carriage. And then for this tower, the solution is, as you can see, there's a wire coming here. There, I saw from some other YouTuber, they had used these welding tops, or whatever you call them. And then I put wood inside to isolate it, because I have ABS plastic here. And this can get fairly warm, quite warm. I'm pushing about 50 watts right now through this cable, which might be too much. I don't know, I'm not an expert, I'm still tinkering. And yeah. So the wire goes in there, out there, and then around here. And the reason for this steel is, again, the wire could be hot at this point, so I wanted to isolate the heat. And if there was going to be heat, I wanted to dissipate, and this has worked great. Then the wire goes up around here, and these move. And these create the pressure for this cable. You can hear it. So they're just hanging here. That's why I use my trusted Texas original steak sauce for this, to create the pressure on this wire here. You need about 2 kilos from my understanding, or 20 newtons of force, same thing almost. And for this I have a smaller motor that doesn't need more. I would probably go with a little bit larger, like 48 millimeters. You can see this is 40 and this is 48 millimeters. This is better because yeah, it has to pull it up and down, and I am pulling wings, not straight wings. I'm actually doing like delta wings, which are like this. And then there becomes a lot of tension sideways. This wire doesn't go like this straight like it does right now. After a while, it starts bending towards the other tower, because they go in at different speeds to create this 3D shape. And I'm just having normal NEMA 17 cables from that, running pretty long ones, 1.5 meters. And it goes to this one. So this is just a 3D printed shell I put on top. I have a small display here, and the controller is a Pibot. Cost about $60. And on top of that, I have 4 motor drivers, since I have 1, 2, 3, and 4 motors for each tower. And these are TMC 2209s. And yeah, it was a bit messy. You have to learn how to see which cables goes into where by pulling 2 of those cables together and then turn it around. And if there is resistance, you know that's the ones that should match. So yeah, some of these cables are straight like this one, and some you can see are turned to be sure that they actually go to the right output. Over here you can see I do not have any end stops. I'm using soft end stops, so I'm basically just manually sitting there and telling that, okay, now I am at 0, and then I just zero it. And that's actually something I could show for you. I think that's pretty cool. So let's just restart that one. To control this, I'm using a jog. So I don't know what I'm doing here now. Forget that one for now. We can just continue. You can see that there's a fan. I'm a little bit scared that this is gonna be too warm, these controllers. They get pretty darn hot. So I have a 24 volt fan there and a duct pushing that in, and you can really feel some heat coming out when you run it. If we move backwards from the Pibot, we can see that we go to a distribution block, which has the negatives and the positives there. And if we follow then that one, we can see that we have 2 main channels here. One with the positive, where I have what's it called? A fuse. Why? Well, because you don't want things to blow up. You want the fuses to take shit, not the cables. You don't want your cables to burn. And you can see that moves over to this AC to DC converter, DC supply. So we have AC power coming in here to this one. And for the AC, I have this block that I can turn it on and off with. It also works as a fuse. And also in here, I found out the hard way when I was playing around. I actually wanted to control the heat from this Pibot. So I was using a solid state, what's it called? I don't remember. Yeah, it's a block that regulates the DC current. So I could take 24 volts there, push it into this little circuit, and then opto-isolated, which means that the current will not fly into, or a voltage, or the current will not flow into the Pibot. It's isolated. It will just tell it how much voltage and how many amps it should pull, and then it would you could kind of more precisely control how much current is actually going into the wire. Turns out that was not needed because I have this, and this is just the amps and the voltage. If we turn it on, we can see what it becomes. We can see that it's at 23 volts and 2 amps. That seems to be some 24 volts, 2 amps, 50 watts. That seems to be magical. It depends on the resistance of the wire and of course the length. And yeah, I just used ChatGPT or Gemini for this actually to figure that out. Another resource that would be great to follow on this is RC Keith. He makes a wonderful website and a wonderful YouTube channel, so follow him if you're interested in 4-axis CNC cutters. So yeah, now my wire will be heating up. Yeah, you can kind of feel it. It's hot. And how does it do that? Well, you take the positive and negative, one negative there, and the positive over there, clamped on. Not the best solution. I don't really like it because it could kind of snap off mid-print or whatever you call it, mid-cut. Great, so how did I get this going? Well, let's see if we can do something here. There. Here we have a thing I built. We have FluidNC. We have 4 axes. And actually, if you would use this one, this is called the FluidDial. I just 3D printed it, and yeah, for some reason it dies. I don't know why. Something is going wrong. Yeah, this is what happens when you do DIY projects. You have to figure things out. I guess there's some power issue here going on. Anyways, so let's go back to the computer and start looking at what kind of software I'm using. I'm actually just using this hotwirefoil.coolpix.de, which seems to be some guy that created this. Pretty nice software. You, for some reason, it's using Swedish, German, English, I don't know. Anyways, you just select the outer foil or tip foil, and you select the root foil. And I have downloaded those from airfoils.com using a .dat file. I say how wide the wing will be. I will say how many points. I guess that's how many dots you get for these to create a shape. I'll probably increase that to 600-700 actually, because I'm doing such big thing here. Then you can take the root profile, and that's this one, the inner one. And you can say how many millimeters, if there's going to be any twist in it, and it's going to be any scaling. You can set the tip profile, same thing. But there you can also do leading edge sweep. So if you think a normal wing would go kind of straight, but delta wings go backwards, and also have a trailing edge sweep to the forward. It's not even straight in the back. And you do that to have more optimal lift distribution, elliptical lift distribution, or closer to elliptical lift distribution. Well, there's other reasons also, but let's not get into that here. And then you just put the machine data in, how big your machine is, and you put the foam block in, and yeah, then you generate this G code that you can see here. So G code is just what this machine is run on. It tells like for every, like where it's going to move next. And then you can export the project, or you can save the project here as an NC file and you get it out. So yeah, this is the software I use to create the code that my CNC will run on. And over that, let's see, what's it called? UGS, Universal G Code Center. So I'm running this Mac on Linux actually. The Mac just became too slow, and on Linux it's a beast again. And we can see firmware. Let's disconnect it. So it's connected through Wi-Fi. And you can see that it's connected to FluidNC here. So we can now see that we are 000. And the machine doesn't know. I just need to push these things back and make sure that they actually are at 0. And then I just set 0. Or yeah, they are at 0 already. And then I will just, from that file I just created, I will just do recent, and let's open another one, G-code, latest G-code. So you can kind of see it. This is not a 4-axis visualization. This is one of the limitations of this UGS, or Universal G-code centers, but yeah, it works. You just click play and it will send the commands. This is the file that was created with all the positions that it should move to, and yeah, that's pretty much it. What more do we have? We also, of course, can connect to the machine. .34, I think I'm using 3.4. Yeah, here. So this is the interface for FluidNC. That's what that control over there is running on. And we can do all these things. We can send commands to it. We can move things. We can probe. We can open files. We can run things. And how did I program all of this? You know, in the old days, I actually had to sit endlessly and do a lot of that. Nowadays, I just use anti-gravity. So anti-gravity is an AI tool, and I am just talking with it, and it's sending command. It built a script to connect to my controller over there. I work as a programmer, so that wouldn't be an issue, but it would take a lot of time to build that, like a lot of time. But using anti-gravity, I do lots of things. Like if I see the file not matching, I can just talk with it and say, okay, this file we had in UGS, the G code file. If I see something that looks really wonky, okay, so instead of just trying to figure things out constantly myself, I just get to write here exactly like a chatbot. Like, okay, this happens to my stepper. Like for example, you need a configuration file, and a configuration file looks, I don't have the YAML file here. I guess I could find it here. YOG files, there, flash. And we can see I have many here. So let's download that one. We can no. Let's open it. Keep, there we go. open. There we go. So if I open it with a text editor, this is the configuration file you can see for my four axis. And this means that I can actually reuse this one for my other CNCs. I don't have to have many of these. I can have one. And then I just say that, okay, this YAML file, which is the configuration file for that controller, that will just be used in this one. And it has everything. I have literally not looked at this almost. I just use the AI to tell it everything it should do. And then I double check that it does what it does or what I told it to do by running it. And it just works. It's just so easy to do these things nowadays. So if you haven't met this, this is just, it looks really like a chatbot, but it's called anti-gravity. It's mostly used to build software. And if you looked at the jogging interface I had before, I think I might have screwed up something with a power cable there or USB cable. Yeah, it didn't have 4-axis support. It only had 3-axis support. So I just told anti-gravity to, download the open source project of this, what's it called, FluidNC interface. Really weird that it dies. Hasn't done that before. Let's see. Here's the FluidDial. Goes on Wi-Fi. And now it's connected. So let's see. There you can see 4, but the original one only have X, Y, and Z. I added multi-axis support, so almost an indefinite list, but it will become too small. But I tested it with 5 axes, and I wanted to do that to also help the community, because the community, I mean, not everybody just uses X, Y, Z. That's a standard CNC, but you might use 4 or 5. And yeah, I pushed this change, so hopefully the guys who build FluidDial can take my pull request and integrate that to the latest version at some point. I have not checked what they've done, but if they do that, everybody would benefit. So everybody will get 4 axes. So you can, yeah, now it didn't die. So let's play with it. So we take the X axis, and you can see it moves by me just holding there. There's sweet. And we can zero. And you get a lot of things you can do here. So, which is pretty cool. You can jog, you can do settings, macros, open files, change the tools. Yeah, lots of nice support here. But this is actually the most useful, I think. So zeroing, putting plus or minus, moving back and forth basically. So, yeah. Anyways, oh, now I'm starting to cut. I didn't want to cut. There we go. I started moving too close to the foam. So is there anything more to walk over? Well, I do keep a little bit water if there would be some accident here, having a little bit fire. I don't know. I'm moving right now, so I usually keep what's a fire extinguisher here, but I just couldn't find it. So yeah, better to have something than nothing. So most likely this will be better to do outside. It does smoke a little bit. I'm trying to get rid of that by modifying the amps, the speed, how fast it's going. It's going really slow, like 6 millimeters per second, or even 4 now, I think, to create this clean cut. You can kind of see a cut I've tried to do here. But yeah, it looks pretty sweet. Wait, what are we doing? There we go. So yeah, that's it. If you have questions, just let me know. It's fun to build. I built this, like I said, it's a FluidNC 4-axis cutter, and I will now be extending this one because this big machine you can't have. You have to do something else with it. It's these towers are removable just with one screw there, down here, and so I'll be able to remove these towers so I can store it at the wall. But when I have it at the wall, in a future project, I have now 3D printed this. If you know what this is, yeah, you know. This is lowrider CNC. So I 3D printed this in carbon fiber PET, not PETG. PETG is a very flexible 3D printing material. This is extremely stiff. It's like, what is it, 6,000 gigapascals or whatever it's measured in, the stiffness. And these are PLA. Kind of like this black and green kind of look, and I will have a 1.5 meter X gantry. So if you go back to here, that's Y and that's X, and my idea here is to make this a multi-tool. So I can sometimes use it for 1.2 meter times 2.4 meter full-sized, what's it called, plywood sheets, but I would have to tile it, kind of put, you know, cut one piece and move and cut one piece and cut one piece. But yeah, so I will have to redesign this and probably the whole drive system here a little bit later, but that's okay. I can do that later. At least I have a fully functioning foam cutter now. I have done tons of test cuts, as you can see here, and I think this is going to be a blast. And what I'm going to use for this new multi-tool CNC is this. I was stupid. This cost like 37 bucks at Amazon. No, not Amazon, AliExpress. And it doesn't, I didn't buy the variable adjust speed one. So I had to buy this one. So yeah, you basically take the mains in and it chops it up, I guess, like a PWM controller, and chops up the voltage so that you can adjust the speed. But that's kind of nice because I really would like to have it on the side instead. I don't want to kind of, when it's cutting, I don't want to kind of try to hunt for this one and set the speed if I need to change it. I want to be able to modify it on the side, probably connecting it even here on. So when I get the case around here, I probably have to redesign it, just put it on a black sheet of plywood, and yeah, have it there so I can control the speed. So that's how I'm planning to do a 4-axis and a 3-axis CNC. And the span will have to be increased. So now it's just 80 centimeters, 60 in the center because I have the motors here. That was a mistake. But yeah, I probably should have put it here and just let it run there, but it needs to be the center between these wheels. So yeah, that's what worked with that design. Not optimal, but it works. And yeah, if you found this video interesting, you know what to do. So if you want to support guys that does these videos, and yeah, if you have any questions, just let me know. I thought this was a fun project. It's probably going to save me 100 to 200 hours printing, because if you print a wing that big in 3D printing, like lightweight PLA that some people do, that's just endless of work. So my idea is that I cut 2 wings that are this big, and then I 3D print the fuselage, and I put a carbon rod straight through, and out comes like a 1.2 to 1.4 meter, I haven't decided then, but yeah, 1.2 to 1.4 meter RC drone. That is going to be a blast. Cheers! Hope you enjoyed the video. See you next time.